Hello again, everyone. So we are going right into the next session, which is to discuss the future of robotics. We have an awesome panel, and maybe I'll talk about the robotics industry a little bit before we dive into the panel. So robotics is one of those domains that truly embodies the 100x ethos, combining AI, hardware, and design to transform how we work, how we engage, and how we get things done. So thrilled to host this discussion with the four of you. But let me just quickly get all of you to introduce yourselves within a minute, if that's okay. Kahini, we'll start with you.
Hi, everyone. I'm Kahini Shah. I'm a partner at Obvious Ventures. My background's in electrical and computer engineering from Carnegie Mellon. Been working in the applied AI space for a while. At Obvious, we have a history of investing in robotics, from Dexterity, a truck loading and unloading parcel sorting company, Pika, autonomous flight, and a stealth foundation model of manipulation. Great to be here.
Good morning. My name is Péter. I'm the co-founder and CEO of ANYbotics. We're a Swiss-based robotics company. We build four-legged robots for industrial inspection. So imagine four-legged robots fully autonomously running through facilities and collecting important data to keep the plants running safely and efficiently.
Hey, I'm Jonathan Hurst. I'm the Chief Robot Officer at Agility Robotics and a co-founder of the company. I'm a professor as well at Oregon State, where I started up the robotics program there. So I'm a technologist, and this company is a spin-out from my lab. At this point, we have a humanoid robot that is picking up boxes and moving them other places. And that is the beachhead market, the first place where we believe that humanoids can actually have economic impact in the world. On the path towards these human-centric machines becoming part of everyday life. So that is our mission at Agility Robotics.
Hi, I'm Jenny Reid. I'm a Programme Director at ARIA, the Advanced Research and Invention Agency. That's a new UK government funding agency loosely based on the ARPA model here in the States. We fund science and technology research across the whole of science with a view to societal benefit, and the programme I'm leading funds research into robot dexterity.
Great. Welcome, everyone. It's great to have you here. Let's start with one of the hardest but most important questions in robotics. How do you go from breakthrough technology to real-world value? And Péter and Jonathan, I'm going to ask you to open it up for us.
Oh, boy. I mean, so here's an interesting tidbit, and tell me if this fits your version of history as well. We're starting to see, say, reinforcement learning approaches and ideas become a real foundation for control of robots. Maybe even just 5 years ago, the state-of-the-art was model-based control, and you have to write down an equation of the model of the system and then run an online optimizer on your robot to then figure out what the robot should do. And it's incredibly hard and challenging. And now, RL-based in simulation, trained in simulation, and transferred to the robot is outperforming a lot of model-based control. And the two seeds of that were at ETH Zurich and related to ANYbotics, and at my lab at Oregon State, pulling from the graphics community. And so we had the first biped that was balanced and running outside with this approach, and you guys had started it with the actuators, and then that kind of expanded into doing the whole dynamic control for the quadrupeds, right? And so those two seeds, and maybe more so from the ANYbotics group, because that had a connection to NVIDIA that then produced the tools that Isaac Sim and Isaac Lab and then people are now using to sort of, just like fire, get out in the world, and everybody's starting to recognize the value of this. So software can move fast. Hardware is so much slower. Our company's been around for 10 years now, and it was another 15 years before that of trying to do the foundations of the science in the lab first. And there is a big gap, Our first product, we sold 10 of them to researchers, and we're not yet quite to the scaling point. That's coming next year. That's a long gap, so it's really a challenge, but the potential benefit is vast. So that's the other side of it.
I mean, the topic is real, right? How do you go from research to value? And I think I'll say a provocative statement, but nobody wants a robot, right? We have to come to the realization that the robot is just a vehicle to do something. And for us, really the challenge, or we dissected it in 3 distinct phases. Number one, it's the exploration phase, where you essentially, like a pot of spaghetti, you see what sticks and you publish videos and you talk to as many people as possible. You do a lot. The focus area is POCs, proof of concept, and the channel that you do is really just listening inbound, and you start to see, you connect the dots, what's resonating, and then you have to focus again. The company grows, but you focus more. Second step is then optimization. Core focus is product market fit, really digging down into the specific use cases that you're solving. Does the customer understand the value, ROI models, all of that? And the third step is then exploitation, where you're just repeating the same motion over and over again, more focus, using the same accounts to grow those. But you have to be very clear on what phase you're in, what phase is the market. And as I mentioned, nobody wants a robot. They want a job to be done. And so for us, it's really digging deep and building the entire tool stack around it. So for us, the robot platform is the core enabler. We lovingly call it the walking server, right? The software is what's the value, what it provides. And so we're building a whole bunch of software in the cloud because the workflow consists of the platform, the autonomy, but then a lot of application layers on top. And you have to be crystal clear what you're solving, how, and for whom.
Great. Thank you for the... Yeah.
I want to add to that. Like, we had the experience kind of where... maybe not quite literally, but really close. We discover something or figure something out. We're like, check out this really amazing technology. Imagine what it'll be able to do. And the response is, nobody cares. The customer is like, we don't care. And it doesn't matter. And it's about what problem do you solve? And we looked at literally hundreds of different use cases. And we did POCs of the things that we imagined would be really useful. And then finding that right match of what's the very first place where the technology can provide value to somebody. I just had no concept or idea of just how long it would take and how much work it would be to really understand enough of the different use cases to find the right niche and the right place for that match. Really challenging.
Yeah, very insightful. Jenny, I want to stay on this question, but get your perspective as well from a national innovation lens perspective. How does ARIA think about this whole sort of bridging the gap between early stage innovation and value creation at the national level?
Yeah, it's certainly something we're thinking a lot about because we're aware that it's a huge challenge. And perhaps, maybe you could argue, especially in the UK, we've got this strong tradition of scientific research, but it hasn't always led through into, innovation and companies and impact, certainly in Britain. So we're thinking hard about how we can facilitate that. We're working with a number of activation partners, including VC companies and others, to help the people that we fund achieve that, get across that gap. I don't know if we've got the answers yet, but it's certainly something we're very much actively thinking about.
Got it. And Kahini, from an investor standpoint, what signals do you look for in terms of which startups have really started to cross or have already crossed the commercialization chasm?
Yeah, I think my observation is from our companies, the journey isn't too different than what Peter or Jonathan have described, and we're just meeting companies, whether it's seed, A, B, along that journey, right? So we've been lucky enough to back really great technologists, but great business happens when technology solves a real use case, like you guys mentioned. And we see companies going through 4 steps, right? One is customer discovery, just understanding the tasks to be done, the processes. We've seen great BD people be on the road 75% of the time, just understanding the customer. The second thing is aligning the tech roadmap with the customer use cases. What can you do today? What is the wedge? And where do you go in the future? And that's much easier said than done. It sounds so obvious, but it's so difficult for hardware companies. 3 is really picking and choosing those pilots, those non-recurring engineering engagements. We really encourage our companies to pick something that is not off their roadmap and could actually move to a real production contract in the future. And then the third thing is ROI, just really understanding what customers care about. Is it throughput, speed in industrial settings, safety? And then 5, it's, okay, if we get all 4 of these right, how do we scale the unit economics of the business? How do we operationalize it? And we see kind of great, and we meet companies along each phase of the journey. And what's really exciting, I think, about this new era of robotic foundation models is this promise of being able to do more tasks right out of the box, zero shot, or with fewer training samples, I think that'll shrink the time to market for a lot of this next generation of robotics companies.
Great. Let's talk about biomimicry. So when we observe humanoid or quadruped robots, or even the dexterous end effectors, the resemblance to living organisms is striking, right? What drives this tendency towards biomimicry in robotics, and to what extent is mimicking nature essential for advancing performance, adaptability, and human-robot interaction? Peter and Jonathan, then Jenny.
So we never approach it from a biomimicry perspective, but more being inspired by nature. And so for us, the four-legged system clearly came out of the inspiration, looking at animals, dogs, goats, climbing in the mountains, how flexible, versatile they are, because the world is such a complex environment, and nature told us, what are the most efficient systems to conquer them. But I think so then you start building your robots, but then we didn't go back, to study the muscles or all other things. For us right now, it's important, though, that we embed a robot within a human workforce. People see a soul, a brain behind a walking machine. And so it's important to make sure that people and humans collaborate nicely. It fulfills the expectation of what the robot can do, what it cannot do. How do you design a system that feels approachable, safe, right? Even though some customers might fear, hey, this is an AI Terminator robot, right? So how do you break down the barriers and build human and robots to collaborate together? And a lot comes from the looks, from the sounds, the movements, the transparency that the robot provides. I think there we can learn a lot and implement a lot from the psychology of humans, how to approach machines.
Yeah, I'm entirely aligned. It would be nice if we could come up with something we can argue about. But think of the biomimicry is like a trap that can crush and destroy companies, kind of like the legend of the sirens and drowning the sailors, because you copy all the wrong things. You make a machine, you try to make it look like a person, and it's so tempting, and everybody wants to do that. And then they make all these assumptions about, hey, if it looks like a person, it'll work like a person, it'll move like a person, but it's totally different, like not even close, right? It's, you go to Disney Epcot Center and you see the Hall of Presidents. We've done mechatronics. We've done robots that look like people, but they're not very useful, right? And so our mantra is yes, bio-inspired, and my whole career has been focused on that, and that means look at what's going on in an animal. And we did early on like integrative biology, where we want to understand how walking and running works. But that means we look at guinea fowl and ostriches and ghost crabs and humans and horses, look at all of the morphological differences and then try to find the thread of truth, the physics that runs through that is common to all of those things. Then when we come up with that model that we hypothesize is true for all walking and running, now we ignore all of biology, and then we design something out of metal and motors and computers, which is a different set of tools than biology has, to try and come up with a machine that can capture the same physics and go where people go. So I think that's just laying out a little bit more, how I think of bio-inspiration rather than biomimicry. That's the word that Peter used. And then we are human-centric, right? So we're building a machine that we want to be human-centric, operating on our terms and our environment, where you don't have to design the environment around the robots. And then from first principles, that does end up driving a lot of features that look like an animal or like a person. But if you go about it this first principles path, you know exactly why, and all the functionality is correct. And we are ending up at bipedal, bimanual, upright torso. In fact, we are going to have a forward knee, like a humanoid knee, because it's better for lifting heavy things and manipulation than our more bird-leg robots like we've had in the past, which are better for walking and running. And then for the head and the face, it is human-centric, remember? So you have to communicate to the people around you. But if you look at comics, they do a very good job of that with a very small number of lines. Very, very visually simple things get across the complexity that you want to get across people. And so that's more our inspiration, I would say, for taking the bio-inspiration first principles of how to get across the human-centric kind of communication tools that you intentionally want to, without copying the wrong things and landing in the uncanny valley or something like that.
Got it. Jenny?
Yeah, I totally agree with all of that. I'm afraid there's been no controversy here. I think what I would add, we're in an interesting position perhaps where at the moment AI is just amazing and arguably better than human brains, frankly. But when you look at the hardware, I think robotic hardware is still very crude, frankly, compared to biological bodies. So in my programme, we're deliberately funding hardware, innovative components that will hopefully be useful in the future because, as you were saying, Jonathan, it's so hard to innovate in hardware, so we felt that was a gap we could usefully plug. And I think the other thing that strikes me is that at the moment, too often it feels like a robot is designed by a mechanical engineer and then handed over to a computer scientist to animate and figure out how to control it. And I think as a result, you have, they can control it, but they do so by throwing a huge amount of compute resources at it. It's very cognitively difficult, a bit like when a human teleoperates a robot, bringing the vast power of the human mind to bear on that. And then you look at animals and you see something like a bee with 1 million neurons doing amazingly complex tasks, and you feel like we may be missing something. And I think part of what we're missing is that in biology, bodies and brains have co-evolved, obviously, for millions of years, and so they're deeply integrated in a way that they're not yet in robots. So as part of the work that we're funding, we're looking at co-design techniques. So we're trying to see, can you use reinforcement learning and go one step further? Can you do like end-to-end learning of the body design as well as the control policy? And that feels like trying to get more towards what biology has achieved. And so I would view that as bio-inspired, even though it might come up with, say, robot manipulators that look nothing like human hands, because that may not be the best shape for the job, given the materials you have available.
What you're saying, that's a core principle at our company, right? We used to have, to build hardware and software and AI in unison.
Yeah.
The full stack, this is so important. We used to have 2 teams. We had a CTO hardware, CTO software. I believe you guys also had such a similar story, right? And so for us, we whenever I hear hardware, software, no, put everybody in the same room, have them work together. Because that's exactly the point, right? The reinforcing cycle of software, hardware, and AI now in the mix, you start building your hardware differently, knowing what AI can do with it.
All our best controls engineers were mechanical engineers by training.
Yeah. So systems level thinking versus component level piecemeal thinking, got it. And also borrowing from the nature or getting inspired from the nature versus just copying the nature. Got it, great. Let's talk about manipulation. There's a lot of momentum in the field of robotics in the manipulation space. Do you see the current advancements in robot manipulation as having reached an inflection point? Or is there still more room for innovation? And how transformative could widespread access to manipulation skills be in terms of unlocking new value for various industries?
I think manipulation is inflecting, and it's the most exciting topic right now in robotics. Why is it important? Trillions of dollars flow through the human hands, and it's not about replacing jobs, it's about doing jobs that are dangerous. Meat packing, trash sorting, what agility is doing with box moving, that's one of the highest rates of injuries that people suffer in an industrial setting. It's about supplementing labor that's scarce. We have an aging population. There's nobody to take care of the elderly. It's about giving access to things like robotic surgery. All of this value is unlocked through manipulation and through more dexterous manipulation. And so where are we today? I think if we look around at Pi, Gemini, some of the things our stealth robotics company is doing, we're seeing early signs of generalization. There's still a lot of work to be done, but robots are operating in environments they haven't seen before, manipulating objects they haven't seen before. And talking about biomimicry a little bit, what makes the human hand so amazing, right? It's versatile, or put in the terms of robotics, general. It's fast, and it's reliable. So we're starting to see this idea of generality, but speed, reliability, I think these are still unsolved problems that need to be solved. And maybe, again, taking inspiration from biology, what makes the human hand so cool? It's the 17,000 mechanoreceptors, understanding force, understanding contacts. I'd actually love for the audience to do a fun exercise with me. If you have something in your pocket, try to pull it out. Go ahead, try to pull it out. How did you do it? You used touch, right? You didn't even use vision. You didn't need your eyes. Rodney Brooks said this recently in a blog post, but one of the keys to unlocking better manipulation that is general, fast, and reliable might be not just in vision, but also in force and contact sensing. So really excited to see where this field goes forward, and that's like a little bit about what our company is working on.
Aligned, right? Again, I would love to argue with you about something, but I feel like manipulation is maybe 10 years behind locomotion. And it's truly enabled by some of these new AI approaches to control that people are starting to figure out. But it's really trapped behind hardware, to your point. The hardware for manipulation is not good yet, and nobody has a good hand out there. And it's a really frustrating difference between perception of what people think based on what something looks like and what it's actually physically capable of. So we see lots of robots with these five-fingered hands, and it drives me nuts. Agility gets the question all the time, when are you guys going to do dexterous manipulators? It's like, well, actually, our robot is far more dexterous than almost any of these robots. Look, we're lifting these 16-kilogram totes and swinging them all around. It's a big bimanual manipulator. It's highly dexterous. But if you put a five-fingered hand on and all it does is maybe this, thing, people are like, wow, that's amazing. It's, again, the hardware is really limiting. It looks something, it's biomimicry, it looks something like it, but it's actually not. You can't do all of these kind of compliant force control kinds of things with hands. So that's something where I think that we really, really need to make some significant progress. But everybody's looking at it now, so we will.
So big plus one again, tactile sensing is obviously completely crucial, and we're funding, I think, about 6 teams investigating different approaches to tactile sensing. Obviously, it's very challenging because if you have a lot of sensors, that's a lot of wires to read out that information, or the other approaches you can take, it's going to be really challenging, but I think it's so critical. The other thing to mention is actuation. So I think one of the key things about the human hand is the number of degrees of freedom it has. 27 it's generally classified as. So if you have that many degrees of freedom, you need a lot of actuators, and that then becomes big and expensive and heavy and bulky. So we're looking at funding groups investigating different actuator approaches as well. I think, as you said, Jonathan, about the hand shape, I think people fail to recognise just how complex a hand is. Like, look at the way your palm moves. You get a lot of robot hand where there's like a flat board and then there's a thumb and some fingers, and I think that's missing a lot. There's also a lot about the friction between our fingers and surfaces. It's really important. And the softness, the way our fingertips squish around objects, is very important to our dexterity. So I personally believe we're going to need, if we're going to get close to human-level dexterity, we're going to need to think about making robot manipulators with those properties as well.
Well, now, hey, we're talking about biomimicry, aren't we?
Well, yeah, we're talking about existence proof, right? So,
well, it's true. So we make all these observations about things that we think might be useful, but we're not exactly sure from a manipulation point of view. Like, we're so far behind in robotics understanding how these things are useful or why they're useful. My favorite example is the European cybathlon. Are you guys familiar with the cybathlon? It's a competition where disabled people can technologically augment themselves, and then they do competitions, and they'll do things for hearing and sight and things, but there's also a manipulation competition, right? So people wear prosthetics, and then they just have to do a bunch of tasks that really require some manual dexterity. And last year, it was so interesting, the winning entry was a basic parallel jaw gripper, a 2 degree of freedom parallel jaw gripper. And so a woman wearing a prosthetic with just those 2 degrees of freedom was able to beat out every other five-fingered hand, complex, dexterous manipulator. It didn't have force sensors on it. It didn't have, anything like that. It's just that the intelligence behind that, if you imagine how dexterous a person with chopsticks can be, that kind of thing.
Yeah, although they have force sensing, right? They can feel the forces relayed through the
I'm not sure.
chopsticks.
I actually don't know. She may or may, well, for chopsticks.
For chopsticks, yes. So, I don't know about...
Yes, and force is critical. I'm 100% convinced that force is just absolutely critical for manipulation.
It's the difference between flexibility and speed, right? The more flexibility you have, the slower you are to adapt to different use cases with the same hand and actuators.
I don't know.
In your example, the woman with just that gripper was able to perform the tasks faster, right?
But there are a whole bunch of them. There was like the, tying a knot and, moving a hoop over a wire, and like there's a whole set of these things, and they're timed, and they also get to completion for it. And so just broadly, as they were trying to come up with examples of this, broad an example of what would we define as tasks that a dexterous person could do, and now how can people who are technologically augmented but don't have their natural hands can do.
But even thinking intuitively, right? Wouldn't it be harder if you just had chopsticks, right? You'd be like, oh, how do I like do this, right? Like, versus like
Human hands are clearly more dexterous than chopsticks, right? Yeah. It's just that no robot five-fingered hand gets anywhere close to a robot parallel jaw gripper yet.
Right, but even like a parallel jaw gripper with force sensing and contact sensing would probably be better, right, than one without it.
In theory.
Yeah.
Now, has anybody shown a parallel jaw gripper with sensing and then shown performance that outperforms a regular parallel jaw gripper, given what we know about how to control them yet?
How do you measure that performance?
I don't know, that's a good question.
Great. I love the discussion. Let's keep going with that. So let's try to spice it up. There is an ongoing debate in robotics about the relative importance of hardware and AI. Right? How do you see the interplay between great AI and great hardware shaping the next era of robotics?
I think for robotics, as we've talked about already, hardware and software are coupled. They're both defined and constrained by each other. And because I'm a VC and I love patterns, I think there's a parallel here to the mobile phone and how that evolved. And they're both, devices after all. So the early days, like we started getting better keyboards, compute started shrinking. That led to BlackBerry building some software on top of it, right? And they showed how powerful some email and messaging could be on a cellular platform. And I think from there, it was software and what users wanted that really started pushing hardware forward, right? So if we think about the iPhone, shrinking cameras, touch screens, this was all driven by what we wanted on the software side. We're seeing it again with like AI, more chips that are specialized to run on the phone. I think it even like kind of answers this debate of do hardware and software have to be tightly coupled? Like you see the benefits of doing that in the iPhone. Can they be decoupled? You see in Android like the pluses and minuses of doing that. And I think for robotics, we're moving from maybe this hardware-defined era to software pushing hardware. And I'll let Peter and Jonathan comment on this, but we're definitely, I think, ahead in locomotion in terms of hardware and what hardware can do, and manipulation and dexterous manipulation in particular. I think we have some cycles to go.
So for us, the hardware for many years compensated for the lack of appropriate software. As we mentioned, right, in the model-based controlled era, we built the best that money could buy in terms of precision, sensing, resolution, all of that, because software just wasn't ready to power these robots in the same way as they can do today. And so with AI, I think it's turning around, and with the next generation of robots, we can build less precise hardware, fewer sensors, fewer resolution, and meaning that AI starts to eat into the cost of the hardware, right? And so building that together, AI will compensate for it. And I think that's a very exciting trend happening now, because it means lower robot cost, a democratization of robot usage, more use cases, and that's a flywheel that has started thanks to AI.
Yeah, also, I want to say that I do not believe that we will have like a general purpose piece of hardware that then different companies can write software for, and I don't believe we're going to have a general software that controls any robot. I think that there's going to be a lot of gray area in the middle, but in our experience, it's a huge amount about the product design. And so, as we deploy the robot with customers, then we find things like, well, it needs to have this much battery life, it needs to charge this fast, it needs to be able to lift this much weight, and it needs to be able to move it this high. It needs to be able to operate in this kind of space and environment, so that means it needs to be below this size. And then importantly, we run into something like safety. We say, hey, the robot is, in our case, dynamically stable. It's balancing, which means it could fall, and that could be dangerous. And it's a new form of danger and risk that hasn't existed in robots before that have been deployed. And so now we have to figure out a whole standards and a safety approach that then turns into an ISO standard. And that safety approach required a complete ground-up, holistic design of our robot that involved the data bus, the power electronics, the shape of the legs, the shape of the torso, the sensor array and where those sensors are mounted in the torso and the type of sensors they are, redundant computing, all kinds of things that are not software. And so that was an absolute requirement and necessity, and no amount of software could have overcome that. So certainly the hardware is an absolute necessity, and it is not a general purpose thing. It is going to be focused on whatever product segment that you're going to address. And then, we'll use a broad array of software that's going to be general. I mean, you use operating systems for computers, right? And a whole bunch of very customized software for your machine. So it's not a black and white thing.
Got it. Jenny?
Yeah, I'm glad you raised safety, because I think that is a really important question, and one that I don't really know quite how we're going to deal with that with AI, when the programming has been learned, as it were. So that's definitely an issue. I think with hardware, the way I see it is we are discovering how we can do much better with the hardware that we have, but my hypothesis is at some point that's going to hit a limit, and we're going to be like, well, that's all we can do with what we currently have available. So my program's trying to get ahead of that and fund some things that would then be available in the future to enable people to go further. The other thing, I suppose, though, is that actually the AI is opening up hardware that in many ways, as you were saying, Peter, is less capable, right? So in the past, hardware was super precise, we go there with millimeter precision, and that's, again, very unbiological. So not suggesting we have to slavishly copy biology, but it does offer an existence proof that you don't need 1,000 hertz control loop and very low latencies, right? You can work at, tens of hertz and with 100 millisecond latencies if your control is appropriate and integrated with your body. So I think that's a really interesting direction to explore. Because I worry, again, about the cost of robots, that maybe the current direction is requiring an awful lot of compute, an awful lot of smarts to drive these robots, and that just feels like it may not be super sustainable.
Got it. Great. So what I'm hearing is AI and hardware aren't rivals. They are co-evolving levers for innovation. Awesome. Let's shift gears to talk about the broader market. Let's talk about the hype versus reality in the robotics market. So this is more for Kahini and Jenny. The industry is surrounded by a great deal of excitement, but a lot of ginormous size rounds are happening in terms of financing rounds. So how do you separate the hype from reality in robotics as an investor and as someone who values this from a national innovation lens?
I'm not sure I've got a great answer to that. I suppose trying to dive into the technical details a lot and not be distracted by the hype, but be like, okay, what is the innovation here? What is your project going to deliver? Why will that be good? I think maybe I'm further away from the hype because we are trying to deliberately fund things other people are not funding. We have relatively small amounts of money to invest compared to what's going into robotics at the moment. So we're always looking, where's the white space that isn't so much generating excitement now but could be really important in the future? And maybe other people here are dealing more with the immediate hype around, humanoids or whatever.
Jenny, I would love to learn from you what those new areas are, but we look at a lot of maybe what we would quote as hype companies. And in some ways, I love this question, right? Because it's so difficult to answer. I think right now, two things are simultaneously true. It is hype and it's not hype. And we won't know till some time passes. And why is that the case? So on one hand, it's not hype because the size of the opportunity is so large and the potential is so large. But the reason it is hype, right? Because it's trading on expectation, not necessarily revenue. And at some point, valuations need to be grounded in something. So we'll all see, this is an experiment we're living through together to see if this is hype or not hype. But I think as an investor, right, we're fiduciaries of our limited partners, and it's really important to us that we're investing in things that are long-term, that are sustainable, that are going to return, just like not a big valuation on paper. And the three things that we do to really try to be in non-hype companies. One is references of our founders. Robotics is a very small community, and it's very fast to find out who is really excellent at this craft and who is not. I think the second thing is really trying to separate demo from production, right? We all scroll our LinkedIns and the internet, and we see like robotic theater. We see robots dancing around and twirling, but it's just a demo. There's a large gap from this demo to what agility is doing in production, like actually doing tasks that add value safely, reliably over and over again. So I think understanding that chasm as an investor is very important, and that like allows us not to get really caught up in the hype. And then the third thing is also just understanding what is engineering and what is research. Even with today's technologies, there's a lot that we can do in locomotion, there's a lot that we can do in manipulation, and we can underwrite to that actual value, and the engineering problems can be solved, and then we're eyes wide open about what are the research challenges that, if solved, unlocks even more value.
This is really smart for an investor, right? So we had an investor that did not invest in us and invested in another humanoids company. And they told us, they said, look, we don't have any technologists on our staff and we don't know anything about the technology. So we're just gonna have to take you at your word, and what you say will work, we'll believe you on that. And we're really just interested in understanding your vision of where this is gonna go. And I couldn't believe that these people have, they have money to invest. How do they still
Hundreds
have
of
money?
millions of dollars.
How do they still have money with that kind of an approach to investing? I don't understand it. But
That's driving the hype, right? Not every investor understands
there's a
the
lot
market.
of money going into things where they are not at all doing technical diligence. They do not understand what's real and what isn't, and they're still putting a lot of money after it. And that's what's driving a lot of the hype right now.
Yeah. I mean, for us, we love working with investors that have invested previously in robotics companies, such as TDK, right, Ventures. It's so different. We see three categories of investors. Number one, the ones that follow the hype, have no idea, right, and just believe it's going to be all hunky-dory. Second, ones that have invested in robotics company in the past, but burnt their fingers, because they typically came from a SaaS environment, and that didn't work out in robotics. And the third ones that truly understood what it means. Technically, the time, the commercial focus, all of that. And those ones are great investors, and we love work. And for us, it's a reference question the other way around. What other robotics companies have you worked with, right? Do you have the full transparency of how hard this is going to be, right? These are very important discussions you need to have.
To wrap it up, let's end on a forward-looking note. What are some of the hard problems that you hope roboticists will work on in the next decade to drive the robotics revolution forward?
I mean, for us, our vision is, we call it creating a workforce of autonomous robots, and we want to see that people in physical labor are not exposed to any risks for themselves physically during their work, but also with robotics we can have a big environmental impact, making sure that renewable energies becomes more competitive, everything offshore wind, etc., compared to the traditional industries. So I think robotics has a huge impact to make on the sustainability of the world and our health.
You know, I think a lot of what's happening with the technology is totally inevitable. Like, we are going to figure out robotic manipulation. We're going to figure out loco manipulation and perception. We're going to figure out how to have robots operate on our terms and operate as part of everyday life and in human spaces. But, like a lot of things that are maybe historical or art, it's how it's done is not inevitable. And so what I really would like to see is a lot more focus on, I don't know what else to say. Like robots that are kind to humans, robots that are not just replacing people and kicking them out of their jobs, but robots that are augmenting people, that are helping our society to improve, that are coming in as helpers, as partners to us, like really, really smart service animals, not peers, and really thinking about how this technology is going to impact our lives, and see if we can make it as positive as possible. And I mean, that even boils down to things like the industrial design of the machines, and so many other things, safety, and then the use cases that you go for, but some of that thought.
Yeah, I've got a few thoughts. I mean, yeah, absolutely. So one of them is that basically an industrial revolution is coming, right? I think we'd all agree on that. And past industrial revolutions have benefited humanity hugely in the long term, but they have not always benefited all humans in the short term. Right? We have not handled them well, which is a real pity because, if the pie is getting bigger, no one has to have a smaller slice. So I would love to see us doing better this time around. And then just going down from that big picture a bit, perhaps, I'm also been thinking a lot about where's the kind of robot-enabled society we're trying to get to. And I think it's clear there's going to be a lot of robots everywhere, and they're going to need to communicate with one another, and they're going to be secure and verifiable. And if something does go wrong, we're going to need to be able to interrogate them about why they made that decision. There's a whole lot of plumbing that just has to happen in terms of communication protocols and the like that I think hasn't, it isn't there yet. So I would love to see people working on that. And I think there's great opportunities actually for startups and so on to come in with tools that would benefit that robot-enabled society.
Similar to what the other panelists said, the framework that I like to use is jobs that are dangerous, scarce, or inflationary. So, like I spoke about before, what are the jobs that humans should just not be doing, like meat packing or box lifting or trash sorting? And that's a bulk of these industrial jobs that we've invested in so far. The other areas are really where labor is inflationary or scarce, and an area that I'd like to dive more into is robotic surgery. And I think you were saying this on like the other panel as well, right? About maybe robots being a companion. If we look at the Amazon Echo, they've sold 100 million devices or something like that. One of the top use cases is seniors talking to it because it's lonely. Because they're lonely, sorry. So I think there are just use cases that we haven't imagined yet. I think we're just at the very early innings of this robotics wave, and we're just going to see things that surprise us.
Will robots take over VCs too?
Will robots take over VCs? I don't know.
The job is dangerous, inflationary. It matches your definition.
I don't know if it's dangerous or that VCs are scarce.
Inflationary for sure.
You guys
Inflationary maybe, but we're going to find out soon.
Do you already use AI in your searches and
we do.
working? So
We do, yeah. We have a AI tag team. Shameless plug to them. Great. So we have 3 minutes left. Let's open it up to audience for maybe 2 or 3 questions.
Yeah. Hi. First, thank you so much. I'm Eric Rosenblum from Foothill Ventures, and we've made, I think, 5 robotics investments now. So it's an active area for us. We look at a lot of robotic components. So you've talked a lot about dexterous manipulation, tactile sensors, et cetera. And we believe that's sort of a pick and shovels bet on the one hand, and it's a clear enabling technology. And then we get worried about China. And we say, well, yes, there's some really interesting innovation going on here, and especially to the extent that it's software-driven, combined with the hardware, and maybe we can see a case that the research here is compelling. But then we say China is going to steamroll these guys in a few years. I'm wondering if you have a reaction to what China means for this industry, and in particular for the hardware components or enabling technologies, vis-a-vis those of us in this room that are working in the US or in Europe, and how we should view that.
So our perspective is commoditization will happen anyways, right? And it's now massively accelerated. And China's doing an amazing job in low cost, but also high quality hardware. So the question is, how do you react to this situation? For us, we'd love to have a global footprint and use the best. That's politically difficult. And so how do we differentiate? We need to be cost competitive, but not cost leading. And so for us, it's just the innovation in the software, the full package. And there's so many layers. What I mentioned in the beginning, nobody wants a robot. So yes, it needs to be good enough and cheap enough, but then the value comes from everything else. And this is how we try to differentiate ourselves in the long term.
I think if you're talking about components, it's a better question for TDK. The global footprint, and how do you have engineering and innovation, and then how do you manufacture utilizing the parts of the world where you can manufacture at a very low cost, and then navigate politics. Agility has really focused on, mostly U.S. and Western suppliers, so that we can build trust with U.S. and Western customers, because we're putting a big complex device covered in cameras in people's very, very private warehouses. So, for us, there's a lot of politics and supply chain to be aware of, but we're system integrators. That's different from, device producers and manufacturers.
Can take maybe one quick question.
Yeah, thanks everyone. Graham Carey from Emerald Technology Ventures. Maybe a bit of a provocative question. Do you still see lights out industrial automation operation as a big driver, and does that run counter to what you were discussing on the human-centric design piece?
Yes and no. So absolutely, in 100 years, are we going to have Amazon warehouses full of humanoid robots? No. It's going to be a lights out, autonomous vehicles driving in, sortation and stuff happening, and then autonomous vehicles driving out. But there's going to be always places for human-centric automation. And our homes are an obvious one, but also like delivering packages to your front door, or working in a grocery store, or working in the front of a hotel, or working in a hospital. So those things are really hard to do right now. So right now, these very human-centric robots can address some of kind of the transitionary periods where we're trying to fit automation in sort of areas, workflows that have been designed for people but really aren't human jobs, right? They're robot jobs, but they currently are being done by humans. So humanoids can start to do those, and then as the humanoids get more and more capability, and as much more purpose-built automation gets built, then just the role of that kind of a human-centric robot shifts and moves.
Great. We'll call it a wrap. Please join me in thanking our amazing panelists for an insightful discussion. Thank you so much.